All right, let's get the show on the road. Hello, everyone. Hope you're well. Welcome to another edition of Math 1000. Hopefully you guys had a good week so far. Let's actually jump into it. The main agenda for today is to actually go through your last quiz 4, I want to say. It was the quiz that you took earlier this week. All right, so let me just move things along here, make sure I can see the chat and everything. Okay. All right, and again, so I, as I mentioned a couple times before, I do know how to like spotlight my video now so that none of you will get recorded. So if you can turn your video on, participate, just try to make this seem as much as in person as possible. It would be much appreciated. And we can continue. Some other things before we move on. So I did give you guys, did I give you guys a schedule? I know I gave at least one of my guys a schedule. So pay attention to the schedule is the first thing I would say. I did mention when our final would be in a previous email. I thought I put that in a lecture, but if I didn't, I will probably do that again. But some things that are immediately relevant that you should remember. So let me just make a note right here in case you're reading over the notes. So fill out the Doodle Poll. If you haven't already. So as some of you already know, because I believe some students from this class have filled it out, it's anonymous to everyone who has filled out the poll. So you guys can't see each other who's filled it out, but I can see everyone who's filled it out. So fill out a Doodle Poll. I sent an email recently that I'd want to hold an extra study hall session to kind of deal with some of the issues that I've been seeing arising this semester in terms of, you know, general study tips, general study habits, how to improve if you're not doing as well as you want to, how do you actually get better over time. And so I just wanted to have like a study session like that with you guys. I send out a Doodle Poll for you guys to fill in when the most people would be available. I would hold it then just to talk about stuff. I would also encourage you during that session, if you have any personal issues that you are comfortable sharing, because you would figure that, you know what, a lot of people probably have these issues. So like your time management issues, etc., that you'd bring them up and I can use those examples to further clarify some things that I've been talking about. So I do give you guys a lot of study tips, but again, when I give you guys as a class, it's very generic. And so a lot of people that I'm finding don't actually know how to apply it to their personal situation. So more specific examples are probably needed. And I'll talk about all of that in the session. So fill out the Doodle Poll. Currently, as I said, I would prefer it to be next week, Friday, just because of how busy I am this week. But I am open to doing it tomorrow. And I do believe it's one of those things where you would want to actually get it over with earlier, sooner rather than later. So currently, the ties for the most popular slots is tomorrow at 2:30 p.m. And the second popular slot is next week, Friday at 5 p.m. So currently those are the guys in the lead and it's actually tied. So if you want to make sure that your time slot is represented, please go and vote in that Doodle Poll. Yeah, so as if nothing else changes now, which I don't think everyone has responded, but if nothing else changes, then it means that around tomorrow at 2:30 is when I will hold this this extra session. So just throwing that out there. And I'm giving everyone until this evening to actually respond. This evening, after 5 p.m. Well, I actually start teaching a class at 5:30, so maybe it'll be like around 7-ish p.m. I'll actually like send out a mass email telling you when the extra session is. But for now, it seems like tomorrow at 2:30. So that would be something to keep in mind. Last day to drop this class or any class is tomorrow, so that you should be aware of. And if we have that study session tomorrow, you might want to actually wait until tomorrow before you make the decision. If you're still currently on the fence, yeah, and this is something I'll talk about tomorrow as well. Personally, I think even at this point, everyone in the class can still pass. So theoretically, it's possible. It's just a matter of really understanding what that would take and knowing whether or not you would have the time or the energy to do it. So a lot of you might think that there is no hope, but there is always hope. It's just a matter of, are you able to actually take advantage of that hope? And so if you're still on the fence, it might be helpful to actually attend the study session tomorrow, and that will help you make a decision, because then you'll know, okay, to get the kind of grade I want, this is the kind of improvements I'd have to make. This is the kind of effort it's going to take. Is it doable? Yes. If the answer is yes, and you're willing to try, then you should stay. If the answer is no, because of legitimate reasons, like, oh, no, you know, I have a certain schedule, or my work schedule won't allow it, or whatever will allow it, just to make sure that you're making the right decision for the right reasons. A part of tomorrow's talk is going to be about that as well. But just for full disclosure, I should let you guys know, and I did let you guys know this has been printed in the syllabus for a while. Your final exam date is also known. The dates of your next quiz and tests are also known. So just, I would admonish you again to start pay attention to the schedule. Including final exam schedule. So the final exam schedule is already up on the forum website. I sent you a link. I also sent you the date of your final. So that was, I want to say, about 2 weeks ago, maybe even a little more. So just make sure that you have a schedule in place and you start thinking about that now, because it's going to be about 5 to 6 weeks by the time you'd have a final in this class and all your other classes. So you really want to make sure you're mapping out the next 5 weeks very carefully. You know what you're doing, when, for how long, why you're doing it, what the intensity. It's going to be very important if you want to finish the semester strong, to have all of that under control. So we will get into that more tomorrow. So until then, I guess we can actually move on. We've already wasted a lot of time talking about this, but I just want to make sure that you guys are aware of some things in the works that you might want to take advantage of. Okay. All right. So for now, we are going to go through quiz 4. Yes, quiz 4. Okay. So we're pretty much going to do the same thing, kind of idea, in the interest of time. So I'm pretty much going to go through and I will essentially do the quiz. If you have any questions, you can stop me, but I want you to see how to actually do these problems, why I did what I did, etc. I'm just going to fully explain how you want to go through these, how you'd want to think about them. If you have any questions, or maybe you tried a different method and you wanted to know, was that valid and would you have gotten credit if you had done that method on a test, you can stop me and let me know at any time. Okay, so again, I encourage participation. Please speak up if you have any issues. Yes, I am looking at the chat, but again, while I'm looking down and writing, I might miss something. So it's probably even better that you audibly just bring it up when you have a question, so that make sure I don't miss it. Okay, that being said, let's actually get through this. All right. So A line passes through the points -2, 3, and x, -3. So you don't know the x coordinate of the second point, but you do know that it has the slope -3/2. What is x? Well, we know that slope equals y2 minus y1 over x2 minus x1. And so you can actually just use that equation. Okay, so you can label any of these x2 and x1 that you want. It really doesn't matter. But let's say, just for the sake of argument, I label this x1, y1, and that x2, y2. Okay, so my y2, so this would mean the slope, which we're told is -3/2, is equal to y2, which is -3, minus y1, which is 3, over x2, which is x, minus x1, which is a -2. Okay, and that looks fine there. And so now this just means -3/2 is equal to -6 over x plus 2. We can flip both sides if we want. So -2/3 equals x plus 2 over -6. I can therefore multiply both sides by -6. That's going to be x plus 2. On this side, negative cancels the negative. 3 goes into 6 2 times. And so on this side, you have 4. And so you would get your x equals 2. Okay. Moving on. Which is the graph of this equation? So here you'd have to match graphs. So like on tests, I'm definitely going to ask you to sketch graphs, but in the quizzes I didn't. So I would either give you an equation and ask you to match it to a graph, or give you a graph and ask you to match it to an equation. If you know how to sketch it, it should be easy. So here you will recall from what we talked about last time, that this basically means your vertex is 2, 4. And so that's automatically going to be something that you want to check for. You'll notice that here the vertex is 2, 4. Here the vertex is also 2, 4, so that fits. Here the vertex is not 2, 4, so definitely this is not the answer. And again, here the vertex is not 2, 4, so this is not the answer. So it's either A or B. One other thing you can notice is that this x squared term is positive, so it also opens up, right? So it's possibly this. And because it opens up, it cannot be this. Right? So the answer is either going to be A or none of the above, right? So now we just need to make sure of which one it is. So there are a couple ways to check this here. Look at the Y-intercept, right? The intercept is always a good thing to check when you're drawing the graphs. Y-intercept, this just means your x equals 0. So this is -2 squared plus 4, which is 8, which actually checks out. So the answer is A. Right, so there I was kind of explaining to you what was going through my head. Hopefully that was clear. Question 3, just to straight up solve a quadratic equation, which at this point, hopefully we're all okay with this. Someone sneaking in here. Let them in. So I have 4x squared plus 10x minus 24. Probably one of the first things I would do is actually reduce this. So I can divide through by 2. Might make things a little bit easier to see. Here, maybe this will factor. We'll see. It'll have to be 2x and x. To get a 12, there are multiple scenarios, but maybe a 4 and a 3 would work. Because that way, out here, I would get 12x in 8x. Huh? I would get 8x, and in here, I would get 3x. And then I look, can I get a 5 from an 8 and a 3? Yeah, if I make it a plus 8 and a minus 3. So that gives me my x is either 3 over 2 or x is minus 4. So this option here. Okay, so that was question 3. Where did I put the others? Okay, there we go. Any questions so far? Are we good? Everyone okay? Let me know if you're still breathing, you're still falling. Okay, all right. Moving on. Another quadratic equation. So here we have y squared plus 16y plus 44 equals 0. So now I want to think of two numbers that when I multiply, I get 44. When I add them, I get 16. That's interesting. So let's see here. 44. Well, that's 4 times 11, which is just 2 times 2 times 11. Can I group these guys in such a way that I can add up to 16? Well, maybe a 4 and a 11. No, that gives me 15. Maybe a 22 and a 2. No. Right. So I can't really play around with these numbers to get a 16. So I probably wouldn't waste my time anymore on this. I would actually just jump into the quadratic formula because I don't think it can factor. So what I would do is y equals minus b plus or minus the square root of b squared minus 4 times a times c over 2a. Now, it's probably clear that this is negative. How can we see that? Well, this is 16 squared minus 4 times 44. This is 16 squared minus, remember 44 is 4 times 11. Oh, so it's not negative. It actually makes sense. Okay, so this is 16 squared minus 16 times 11. So now what it means that I can factor out a 16. This is 16 minus 11. So this is 16 times 5. So it's not actually negative. Let's actually work that out. So it is possible to get an answer here. This is why it's always good to check your work. So this here is really just 16 times 5. And I can distribute the radical across both. So that gives me 4 radical 5. And then I can divide the 2 into each part. So that's minus 8 plus or minus 2 radical 5. Question 5. Okay, so this is the opposite. So before I gave you an equation and asked you to match it to a graph. Here I give you the graph and I'm asking you to match it to an equation. And these graphs are all written in the form where you can actually see the vertex. Here, you'll notice that the vertex is 2, minus 4. Minus 3. Point is right here. Okay, so because I know that, it automatically means that these two cannot be it, right? Because that has vertice minus 2. Right, so for this, your v would be minus 2, 3. And for this, your v would be minus 2, minus 3. Both of these have the vertex being the correct thing. So what I would probably do here is check the y-intercept. So the y-intercept here is when I plug in x equals 0. So that's going to be 4 minus 3, which is 1. The y-intercept here, it's going to be 3 times minus 2 squared minus 3. That is going to be 12 minus 3. That is going to be 9. Yeah, and that matches. You could also find the x-intercepts, or you can even check the x-intercepts for this guy. You'd realize that the x-intercepts would be, you want to solve 0 equals 3 times x minus 2 squared minus 3. So this would mean 3 is equal to 3 times x minus 2 squared. This means that 1 is equal to x minus 2 squared. This means that plus or minus 1 is equal to x minus 2. This means that your x is 2 plus or minus 1. So this means your x can be 3 or your x can be 1. And again, here you'd realize that that fits. Right, so a couple of different ways there you can figure out that B was the correct choice in this situation. So the average rate of change of a function blah on this interval. So we know what that formula is, or hopefully we do. So average rate of change on AB is f of B minus f of A over B minus A. Here, this here is AB. So that means your A is minus 1 and your B is 3. So in this case here, it's going to be f of 3 minus f of minus 1 over 3 minus a minus 1. That is 4 in the denominator. And here we'd want to put things in parentheses because I'm subtracting. Okay, so it's minus x squared. So this is minus 3 squared plus 6 times 3 minus 8. And for the second one, this is minus 1 squared plus 6 times minus 1 minus 8. This thing is wobbling. So inside here, it's minus 9 plus 3 6 is 18 minus 8. Here it's minus 1 minus 6 minus 8. 18 minus 8 is 10, minus 9 is 1. And you have minus 6, minus 8 is minus 14, minus 1, that's minus 15. So that's 16 over 4, which is 4. Question 7, there are a bunch of these here. Okay, let me move it over on another screen. It's going to be a little bit easier. Okay, there we go. Similarly here, I want you to find the roots of this polynomial and then sketch it. So one thing we should remember to find the roots, main goal is to factor. I would factor this. This factors into x times x squared minus 5x plus 6, which I can actually factor into so two numbers, when I multiply them, I get positive 6, and add them, I get negative 5, minus 3, and minus 2. So here I realize the intercepts are x equals 0, 2, and 3. Okay, so this graph is correct, but those guys are wrong. So that's not correct. That's also not correct. That's also not correct. 0, 3, and 2. So that works. Right, so this is okay. 0, 2, and 3 is okay. I also know that the end behavior is another thing that we can check. Because this is odd and it's positive, so I know the end behavior should be the right side is going up and the left side is going down. Also matches here. Okay, so now in between, what I would want to do is I would want to actually see what these numbers are. So it's x times x minus 3, x minus 2. So if I'm checking x times x minus 3 times x minus 2, this is my y value. Then if I plug in, say, x equals 1, this gives me positive times a negative times a negative, which is a positive. So the graph should be on top in there. If I plug in x equals, say, 2.5, this will give me a positive, a negative, and a positive. So it will give me a negative overall. And so the graph should be down here. So this guy definitely fits all the boxes. So this is the answer. Factor completely. And again, this is something that we've spoken about at length. Factoring is super important. We've spent a lot of time on it. So first thing you look for is the GCF. There are none here. So now I realize that it's 4 terms. So factor by grouping is what my mind would go to next. So let's see if that can work. Factor an x squared from the first pair. Factor a -9 from the second pair. Now x minus 2 is a common term. I can factor that out. And then that's a difference of squares. So this is that. You'll notice that this is an answer, but it's not completely factored. It contains a difference of squares form that could be factored further. So when it says factor completely, that was very important here. Okay, problem 9 also has several parts to it. It's probably nicer for me to move it on the other screen. Okay, for this line, find the slope and the y-intercept, sketch the graph. Okay, so boom, look at this guy here. For one, y-intercept is when x equals 0. So I just plug in x equals 0. So my y-intercept is -29/5. So that I know is true. Okay, right. So technically, you know that the x-coordinate is going to be 0 at the y-intercept. Okay, so it already looks like the first one is matching up. Now, what I would want to do for the slope is to solve for y. So if my 3x minus 5y is equal to 29, this means that 3x minus 29 is equal to 5y. And so I can divide both sides by 5. And again, you can see it right there, y-intercept. And that is the slope. Okay, so it also asks you to sketch it. So we know a quick way to sketch things. Right? So one is to find the y-intercept, which I know now is -29/5. For x-intercept, you would plug in y equals 0. So you get 3x equals 29. So this means your x would be 29/3, which doesn't go evenly. So that's 3 point something. Not 3 point something. It's 9 point something. Okay, so I would just put that over here as 29/3. And so the line should look like that. And it should just be a little bit before 10, right? So 10 would be 30/3. So 29, it's very close to 10. This first one seems to have the correct slope and y-intercept. So does it have the also? Yes, this is super close to that. And 5, 6, 7, 8, 9, 10. This is, yeah, this guy matches. Still alive out there, paying attention? Any questions so far? Anything out of the ordinary? Anything looking crazy?
Everything's good.
Okay, all right, thank you. Confirming. All right, find the domain and range. So just remember the domain is a set of x values and the range is the set of y values. So notice here, my set of x values, I can have like from x equals 0, that will give me this point, and it continues on forever, like over there. So that's like your domain. The range is a set of y values. So obviously a y value of -1 is possible, but then it keeps going up as well. So this is the range. So it seems like the range can be any y value that's -1 or bigger, and the domain is any x value that is 0 or bigger. So that works. '11. So it's a select all of apply that apply. However, in my estimation, all these select all that apply things are supposed to be pretty obvious. So no partial credit for these. You either get the whole point or nothing. So which of the following represent functions? Okay, so remember a function just means for each input, there is exactly one output. So if you have a list of coordinates, the telltale sign that it's not a function is if you have the same guy in the first position on the left, but there are possibly different guys in the second position on the right. So you can see, for example, this one is not a function because one outputs 2, 3, one outputs 1, 2, 3, and 4, right? It's always the same guy on the left, so that's not a function. Here, 1 only has the output 1, 2 only has the output 1, 3 only has the output 1, 4 only has the output 1. That is a function. It's a constant function, right? The output is always 1. But every guy has something different. Here, 2, 3, 4, 5. So the guys on the left, they're always different. So that's a function. Here, not a function because I have 1 going to -5 as well as +5. So that's not a function. Moving up, the left guys, 1, 3, -5, 4. All the left guys are different. So that's a function. Another select all apply with a bunch of diagrams. Let me move it on the other screen. Can also move problem 13. That has a lot of diagrams. I think everyone else should be fine. Okay. All right, moving on. Which of the following mappings are functions? Again, all or nothing. Here, 11 has 2 outputs. not a function. Here, the 6 has 2 outputs, not a function. This is a function. That's it. Moving on to the graph. Well, which of these represent functions? So the basic thing when you have a picture is functions have to pass the vertical line test. So you notice that any vertical line will have crossed the function at most one time. So that's a function. This is not a function because here's a vertical line passing through 2 points. It's not a function. Here, any vertical line will only cross this guy one time, so that's a function. Similarly here, any vertical line crosses it only one time. That's a function, at most one times. It might not cross at all. Here, not a function. Vertical line crossing 2 times, not a function. Here, vertical line crossing 2 times, not a function. So those were pretty quick. Now, this problem was testing whether or not you can recognize functions from a table as well as manipulate the values of that table. So this one is probably, I wouldn't say it's hard, but it is something that you have to pay attention to get. Right? If you're being sloppy, it's easy to mess up on this. So not difficult, but it is mixing several concepts. Each individual concept is not a big deal, but you have to know how to put them together. So let's actually look at that. Let's talk about that. So f of x and g of x are defined at, based on the table below. So these guys are functions. So you're not going to identify whether or not they're functions. I'm telling you they are functions. And basically it says, what this is basically saying is that, okay, your f of -1 is 1. This is saying your g of -1 is -5. So your input is here, and the table defines your output, right? So we've seen that in class already. Okay, so now basically when you say f of 1 is what happens when x is 1. That's going to be this guy. And then your g of 3 is going to be what the output of g is when x is 3. That's going to be this guy. So I find the column where x is 1 and I find what f does. Then I find the column where x is 3 and find what g does. And so what this ends up being is, this is equal to 4 plus 2 times 3. So this is 4 plus 6 equals 10. Here, now I want f circle g of 1. F of g of 1 is how we read that. This is a composition of functions. This basically means f of g of 1, right? So g of 1 from the table, I go and I find where x equals 1. G of 1 is here. So this is g of 1. That's -1. So this means that's just f of -1. And so now I go into the table, find x where x is go -1 and find what f is, and you'll notice that that is +1. Oh, we had 3 things to move here. Let me move that on the other screen. So this problem is making sure that, okay, so I tested whether, so we saw various representations of functions in our functions lecture. So I tested whether you can recognize functions and interpret them based on a list of coordinates, based on mapping diagrams, based on graphs, based on tables, and now again, based on graphs, but we're combining concepts. So I want you to actually evaluate these two. So we remember that we're testing our ability to read functions from graphs and actually combine functions. So remember f plus g of 2, that basically just means f of 2 plus g of 2 by definition. So now I would go to the graph. F of 2, what does that mean? Well, I find 2 on the x, that's 3. So this is f of 2. Then I go to g of 2. So 2, boom, it's here, comes across, minus 1. This is g of 2. Now here, again, by definition, this is g of f of minus 2. That's what that notation means. So I would go up, I would find minus 2. I want to put that in f. So if I, this is actually the same. This is also f of minus 2. The output is also 3. So this is just g of 3. So now I go to 3 and notice that g outputs 0. And that's that. Okay, so now testing your ability to manipulate functions and combine them when you're given formulas. So f of x is 2x plus 1, g of x is x squared plus x. And I'm asking you to find g of f of 3. Now, also notice that in part B, I asked you to find g of f in general. So it's probably even nicer to do this part first, because then I can actually use that answer in the other part, right? So this is goes back to what I mentioned, is if you realize you're going to have to reuse a composition function, it makes sense to actually do the general form first and then just plug in a value for the other one. So first, let's find g of f. So remember g of f of x. This is just a fancy way of saying g of f of x. This means you go to g and everywhere you see an x, you plug in an f instead. So this means you have like f of x squared plus f of x. So now I just plug in the f of x. That's 2x plus 1. 2x plus 1. Now I square this. This is going to be 4x plus 4, 4x squared plus 4x plus 1 plus 2x plus 1. That's going to be 4x squared plus 6x plus 2. Okay, so that's this one. And then this one is not going to be that bad, because now I just know that g of f of 3 just means I plug in 3 into the above. Plug in 3. So here I'd have 4 times 3 squared plus 6 times 3 plus 2. 4 times 9 plus 6. Yes, that is 4 times 9. I was seeing if there was an easier way to do this. I don't like arithmetic. Anyway, okay, so that's 4 times 9 plus 18 plus 2. So 18 plus 2 is going to be 20. 4 times 9. It's going to be that. That is problem 16. 17, the last non-bonus problem. Describe the end behavior. Okay, so here we just need to actually know what the main thing is. So first of all, notice that the leading coefficient is negative. Second of all, I want to figure out the degree. So the degree is just going to be the sum of all the highest powers of x's. So in the first situation, I have x to the power 2. Second situation, x to the power 2. Third situation, x to the power 1. Fourth situation, x to the power 1. So that is 4 plus 1 plus 1. The degree is 6. So it's going to behave like an ax to the 6, where our a is negative. This is an even power, so I know both sides should be going down. So as x moves to negative infinity or positive infinity, my y value should be going down. And so that leads us to this. Okay, and yeah. Bonus problems. Okay, let's get through these because we have time. As you can see, that was the quiz. Even after wasting, like essentially wasting 20 minutes of class, we still finished in time. So I think it was a fair quiz. You know, me going through explaining everything. Okay, circle has this equation. What is the center? 4 comma minus 3, and the radius is 6. At this point, you should get pretty good at actually identifying that. Yeah, so hopefully no explanation is needed there. That's just knowing the formula of the equation of a circle and what the pieces would mean. So that was testing your knowledge of a circle. This is testing your knowledge of distance. 4 comma y is 5 units away from the point 1 comma 3. There are 2 possible values of y, which is the smaller one. Interesting. Okay, so this one will require a little bit of work, but if you understand the definition of what all these things are, it shouldn't be too bad. So you remember, hopefully, that the distance between 2 points, x1, y1, and x2, y2, is given by the square root. We derived this by Pythagoras' theorem in class. X2 minus x1 squared plus y2 minus y1 squared. Didn't need that big a square root. Okay, so here, what I would do is I'm going to look at this as say 4 comma y, and look at this one as the 1 comma 3. And then this basically says the distance between these is 5. So this means 5 is going to be equal to, plug in x2 equals 1, x1 equals 4. And then plug in y2 equals 3 and y1 equals y. Right, and it doesn't actually matter who you called x1, y1 and who you called x2, y2. You'll get the same answer anyway. So this means that your 5 is equal to well, in fact, I can square both sides. This is minus 3 squared. So obviously that's 9. So this is 25 minus 9 equals 3 minus y squared. 25 minus 9, what's that, 16? Square root of both sides, you would get plus or minus 4. And so now your y would be equal to 3 plus or minus 4. What I did was I moved the y to that side. And I mean, technically, yes, this should be minus plus 4, but whatever. Let's be technically correct, minus plus 4. You change the sign when you move it over. So your y is either 3 minus 4, which is minus 1, or 3 plus 4, which is 7. So now it says, which is the smaller one? Minus 1 is the smaller one. Okay, the points here lie on the endpoints of the diameter of a circle. What is the center of the circle? Well, it's just the midpoint. So this, as you would recall, is x1 plus x2 over 2, comma y1 plus y2 over 2. Doesn't matter who you call who. I'm just going to call this x1 y1 and this x2 y2. Just be consistent. So this is going to be x1 plus x2 all over 2, y1 plus y2 all over 2. 3 minus 5 is minus 2, divided by 2, you get minus 1. And 4 plus 6 is 10, divided by 2, you get 5. So it's minus 1 comma 5, and that's option E. Okay, and the last, last bonus problem. Okay, so this one was testing on piecewise functions. So this was covered in the lecture after the one that you needed to watch for up to the quiz. And so, yeah. But I believe it's actually in a relatively early section, maybe in section 2.1 or something. I forgot the section numbers. Okay, what is f of 4? So you just look at what region what region 4 would fall into. 4 would actually is greater than 3. And so you only look at this part here. And so you'd plug in 4 into that. So it's going to be minus 4 plus 4. Now, what is f of 8? F of minus 8. You would realize that that's not here. We don't have x equals minus 8 anywhere. So f of minus 8, this is undefined. We did not make a definition for that. right? We didn't define it for -8. So it's none of the above. Okay, and I think that is everything. All right, so the quiz might have appeared long, but it actually wasn't, because a lot of it is pictures. And as you can see, a lot of these, we didn't even actually need any calculations for. A lot of it was testing concepts. If you knew the concept, it was pretty easy to get to the answer. But yeah, including the bonus, we got through everything, even though we even started late. Started doing the problems late. So overall, pretty fair quiz, I would say. Tested your knowledge, tested the important knowledge that I would want you to have. So yeah. Any questions? Questions, comments, concerns? Because that's pretty much all I wanted to do today. Anyone? If you have no questions, you can also just tell me no questions. I actually do want to know that people are paying attention.
I have no questions.
Okay, awesome. Thank you. At least Charlotte is paying attention. So again, I want to remind you guys, fill out that doodle poll because this evening is actually the latest that you will have to fill it out because it might take effect tomorrow. So make sure you fill out that. Make sure you pay attention to the schedule. So look in the syllabus, make sure you know when our remaining quizzes are, when our remaining tests are, and make sure you look for the final exam schedule. Okay, so all that is going to be important moving forward. And I don't know, maybe I can show you guys where to find everything. I think I'm pretty sure I sent you the link here. But sometimes you have to give information in a variety of ways, or people just don't get it. So maybe here, let me show you. Okay, so hopefully you're seeing my screen. You can see the browser. And this will work pretty much any semester. You just go to Google, you type in Fordham exam schedule, or maybe Fordham final exam schedule. And you'll see the link here. Like I said, normally in past semesters, even before the semester, you would go here and you can click on preliminary final exam schedule for fall 2020. Now, it normally says preliminary because they want to be able to make changes, but they usually don't make changes. So here you can go and you can essentially figure out when the finals for all your classes are. I would highly encourage you as soon as possible to actually go and actually map out a schedule of when your final exam is. So for our class meets Monday, Thursday at 11:30 a.m. So that's this row right here. So as you can see, our final is on December 14th at 9:30 in the morning. So make sure you don't make travel plans or anything like that. So you can look at this schedule, figure out when all your finals are, and actually start making out a plan. Start plotting out a study strategy and a schedule of when you're going to study for which class, to be ready by which date, etc. Something that we'll talk about again tomorrow, maybe next Friday. So yeah. So that's where you found it. But I did send you guys this link in an email. Okay. All right. So that being said, we're going to wrap up here. Hopefully you guys followed everything and everything was good and understood. Yeah, have a good rest of your week. Start studying, fill out the Doodle poll, and I might see you guys tomorrow or Friday. Other than that, I will see you guys in the next one. Ciao.